Welcome back, students. Hope you all are fine. We were going through the first chapter of class 9th, the number system. And in number system, we have studied and we have covered all the topics except this laws of exponents. So today we will be starting laws of exponents. You can pause the video. I will maintain a distance from this whiteboard and you can note these laws of exponents if you want. So if you want to note these, you can just pause the video and note these down. So we will begin with the laws of exponents and end with also the laws of exponents. Today our topic is this laws of exponents, and we will dig deeper into this, how they came. So in most of the books you won't find how they have been derived. Might be in some books they have given, but I have not seen it. So today I will show you how they have been derived, how they come from. So let us begin. A into m into a into n equals to a into m plus n. So if where here m is what? M is exponent, n is what? N is exponent. So in all these laws of exponents, one thing is common. A is a real number greater than 0, that is A is a positive real number. B is also a positive real number, and m and n are the rational numbers. So in certain cases, suppose here a to the power 0 equals to 1. If I say 2 to the power 0, it will be 1. A is what? A is real number, positive real number. But what if I say minus 2? Minus 2 to the power 0, it will also be 1. Here it is also applicable when A is not a positive real number. Even when A is a negative real number, then also it is also true. It holds true for that also. But taking all these in general, if the real number is, if A is a real positive real number, then all of these laws are applicable. So here A is base and it has a exponent m, and it is multiplied by another A which is base and which has raised to the power n, which is its exponent. In that case, what we get? A will be the base and the exponents will add up. So how does this come? See, we have a to the power m. Suppose m is 2. So a to the power 2 by, and n is your, suppose n is 3. So we have a raised to the power 2 into a raised to the power 3. This should be equals to a to the power 5. 2 plus 3, 5. This would come this. See how it comes? A to the power 2 becomes a into a. This is a to the power 2 multiplied by a to the power 3. A into a into a. So how many a's are there? Total is 5. A into a into a into a into a. So a raised to the power 5. This will become. So in this way you see a raised to the power m into a raised to the power n becomes a raised to the power m plus n. Clear? So this one is covered. Similarly, we have a to the power m divided by a to the power n. This becomes a m minus n. How? Let's see. If we have a to the power 5 and we dividing it by a to the power 3, then what it becomes? A to the power 5 means a into 5 times, a into 4 and 1 5, and divided by a to the power 3, a into a. So this one is 5, this one is 3. What we will get? The smallest will get cancelled. A to the power 3, a first, second and third. What we are left with? Only that part which could not get cancelled. Out of this 5, 3 will get cancelled. So what we will be remaining? We will have only 5 minus 3, that is 2. So a to the power 2 will be remaining. A into a is a to the power 2. Because the 3, the smaller one, that gets cut. So this is how we get a to the power m divided by a to the power n becomes a to the power m minus n. Hope this is also clear to you. We had seen here that a to the power m into a to the power n becomes a to the power m plus n. And since this is equal to this also means that this part will also be equal to this. So we can also write a raised to the power m plus n equals to a to the power m into a to the power n. This is what? This is this one. A raised to the power m plus n equals to a to the power m into a to the power n, because this will again become a raised to the power m plus n. This one. Similarly, you have seen when a to the power m is divided by a to the power n, up to n parts, it will get cut from numerator and from denominator. What you will be having only m minus n. So it will give you a to the power m minus n. A to the power m divided by a to the power n is a to the power m minus n. Up to this, it is clear. Let's say the next one. A to the power m to the power n gives a to the power m into n. The power of power gets multiplied. See, if I say a to the power 2 and it has the power of 3, then it will become a to the power 6. The power will get multiplied. The power of power gets multiplied to make a single power. That is the multiplication of these two powers. How we get this? Suppose we have a to the power 2 and it has a power of 3. What does this mean? It means that a to the power 2 will come 3 times. If we have x cube, what does it mean? X into x. So a to the power 2 to the power 3, it means a to the power 2 into a to the power 2 into a to the power 2. So you know, if you take this common, you know that this will become a to the power 2 plus 2, because a to the power m into a to the power n, what becomes? A to the power m plus n. So a will remain common and as base, and exponents will add up. It will become, this will become a to the power 4 and again a to the power 4 into a to the power 2. Base will remain same and the power will add up. It becomes a to the power 6. So what have we obtained? A to the power 2 to the power 3 becomes a to the power 2 into 3, 6. Similarly, if you have a to the power m into n, it can be converted into a to the power m to the power n, or a to the power n to the power m. Clear? So here you get a to the power m into n can be written as either a to the power m whole power n or a to the power n whole power m. So this thing is clear. Now see, a to the power m to the power 1 by n. This means a to the power m will be multiplied by 1 by n, isn't it? Because what you have studied, power of power gets multiplied. So 1 by n is the power of 1 by a by m, a to the power m. So the base will remain same. With the base remaining same, the powers will multiply in this case. So it will become a to the power m into n by n, m into 1 by n. What it becomes? It becomes m by n. So this is nothing but a to the power m by n. So whenever you are having a to the power m into 1 by n, it becomes a to the power m by n from this law. Similarly, when a to the power m by n is written, you can write it a to the power m to the power 1 by n, or you can first put the 1 by n part and then m part. It will also give you a to the power m by n. So a to the power m by n, you can write a to the power m and here 1 by n, or a to the power n, here m. Both will give you a to the power m by n, because they will multiply. From where? From this one. Now in the last class also I told you that if this exponent is a fractional, we have suppose x m by n. This n is the nth root. This fraction, this part represents the root, and this number in the denominator, this denominator of this fraction represent the nth root. So if it is 2 5 by 2, since this is a fraction and denominator is 2, so it will be the square root of 2 to the power 5. If it is 3 1 by 3 is what? Fraction, and denominator of this fraction is 3. So as the denominator of this fraction is 3, it will be cube root of 3. Clear? So here we have nth root of this whole a to the power m. So nth root of a to the power m, or in this way 1 by n means nth root of a to the power m. So nth root of a raised to the power m is here. So in this way you find a to the power m by n can be written like this. Moving on, we have a to the power m into b to the power m is ab to the power m. A to the power m. Suppose we have 2 and we have 2 to the power 3, and we have one b, another number, that is 3, and 3 is also having the same power 3. So this is of the form a to the power m into b to the power m. Isn't it having the same form? So this will be 2 cube. You can write to the power 3 as 2 into 2 into 2. Sign of multiplication, or this dot, and 3 to the power 3 is 3 into 3 into 3. You can rearrange 2 into 3 into 2 into 3 into what is left? 2 into 3. What do we get? 2 into 3, 2 into 3, 2 into 3, 2 into 3 on pairing. So 2 into 3 is repeating 3 times, and each time it has a multiplication in between. What will be the value? 2 into 3 raised to the power 3. if we have a into a, what do we write? A to the raised to the power, a raised to the power 3. So 2 into 3 into 2 into 3 into 2 into 3, it will be 2 into 3 raised to the power 3. So this is how you get a and b, ab raised to the power 3 m. So a raised to the power m into b raised to the power m, this becomes ab together raised to the power m, because ab forms 1 pair, 2 pair, 3 pair up to m pairs. Quantity of a inside this a to the power m is m. A is available m times, b is also available m times. So if you rearrange ab, it will be m times. So ab raised to the power m. Hope it is clear. Conversely, you can also say if ab is raised to the power m, you can write it a to the power m into b to the power m. Is it? Next, a to the power m divided by b to the power m, it becomes ab whole to the power m. Suppose we have a to the power 5 and b to the power also 5, only the bases are different and the exponents are same. This is of the form as given above. So it should be, as per the exponent, law of exponents, it should be a by b should be common and the power should be the common power, that is 5. So let us see it happens or not. If you take a to the power 5 and b to the power 5, a is repeating how many times? 5 times. 1, 2, 3, 4 and 5. B is also repeating to the 5 times. 1, 2, 3, 4 and 5. You can make a pair a by b, a by b, a by b, a by b, a by b. What you will get? A by b into a by b into a by b into a by b and into a by b. So how many times this a by b is repeating? A by b is repeating 5 times. So it will become a by b raised to the power 5. So if I write a to the power m divided by b to the power m, a is repeating 5 m times and b is also repeating m times. They will make pair. A by b will a by b will make one pair. Second will make another pair. Since we have a and b both m times, so m times the pair will be formed, and it will become a by b to the power m. Clear? Conversely, you can also say, since a raised to the power m and b raised to the power m, this becomes a by b raised to the power m. You can also say that a by b raised to the power m, it can be written as a to the power m divided by b to the power m. So this is what? This 12th number. A by b whole to the power m becomes a by a to the power m divided by b to the power m. Clear? Now a to the power 0 equals to 1. How? I say a to the power 0 equals to 1. See, how you will get a to the power 0? If you have a to the power n, let us write it a little larger. You have a to the power n, and if you divide it by a to the power n, from the laws of exponents you have just learned that you will be having a to the power n minus n, and anything subtracted from itself becomes 0. So n minus n will give you 0. This will become a to the power 0. But from the simple division, what do you know? A to the power n divided by a to the power n. Anything divided by itself. Anything divided by itself becomes 1. So here you have a raised to the power n divided by a raised to the power n as a to the power 0, and at this place you have a raised to the power n divided by a raised to the power n. The value is 1. So this is equal to this and this part is equal to this. These two are same. So the value, this will also be same. A raised to the power 0 equals to 1. Clear? Next one is a to the power 1 is a itself. A raised to the power 1 is a. It is quite obvious. What does this exponent represent? It represents the number of times it is getting multiplied from itself. So 1 is getting multiplied by itself 1 times. That means it is a to the power 2. It becomes a into a. If it is a to the power 3, it becomes a into a 3 times. So if it is a to the power m, it will be having nothing here, multiplied by nothing. So if it is a to the power 1, it will only be 1a. If it is 2, there will be 2a. If it is 3, then it will be 3a, and so on. So if I say a to the power n, it will become a into a into a into a till n times. So if it is n, then n times. So if it is 1, then only 1 time a is there. Clear? Next, a raised to the power minus 1 equals to 1 by a. How this power minus 1 or negative power makes it a reciprocal? To know this, first consider a case when this number a to the power minus 1 you will get. How you will get this one? If we divide a to the power n by a to the power n plus 1, as per the law of exponents you have studied, it will be n and minus n plus 1. You will get a to the power n minus 1. And n will get cancelled and you will have a to the power minus 1. So you have obtained a to the power minus 1 from this. But a to the power n by a to the power n plus 1, what do we observe here? We observe here that a to the power n is a into a up to n times. And this a into n plus 1, this is a multiplied by a up to n plus 1 times. So there is only one n here extra. All the a's will get removed or cancelled by each other, and you will only be having one n over here in the denominator. This will come 1 by n only. So this thing, its value is a to the power minus 1 at one place, and the same thing, this is having the value of 1 by a at the other place. This means what? This means these both are equal. To illustrate the same using some numbers, let's see, we have 2 to the power minus 1. This should be 1 by 2 as per this law of exponent. Let's see. If you write 2 to the power 2 and here 2 to the power 3, you will be having 2 to the power 2 minus 3, that is 2 to the power minus 1. Is it? But you also know 2 to the power 3 by 2 to the power 2 divided by 2 to the power 3, it becomes 2 into 2 divided by 2 into 2 into 2. Both these two will be cancelled by these two 2's, and you will be having only 1 by 2. So this one gives 2 to the power minus 1 here, and the same thing gives you 1 by 2 at its value here. So this means what? This means 2 to the power minus 1 is 1 by 2. So putting a minus 1 over here gives the reciprocal of this number, 2. Clear? We have done this. Now a to the power minus n equals to a to the power 1 by a to the power n. See, this is very simple to understand. A to the power minus n, you can write it as a to the power minus 1 into n. Power of power is multiplied, and n into minus 1, it will be minus n. So we can write it in this form. A to the power minus 1, we have just studied, it is 1 by a raised to the power n. And we have also studied that if we have two numbers and the exponent is in common, it becomes like this, 1 raised to the power n divided by a raised to the power n. So 1 raised to the power n, it will be 1 only, and a raised to the power n will become 1 a by n. So we have a raised to the power minus n equals to 1 by a to the power n. This minus sign is only for making the reciprocal, and this power n will remain the power of a. Clear? Now see, a to the power 1 by n is the nth root of a. How this happens? See, if you have a to the power 1 by 2 into a to the power 1 by 2, what you will get? You will get a to the power 1 by 2 plus 1 by 2. 2 half makes 1. This is also half, this is also half. Half and half makes 1. Or in other words, you can also say, you can take the denominator as 2 and 1 plus 1. This becomes 2 by 2, and 2 by 2 is 1. So this is a to the power 1, or you can say it is a. A to the power 1 is a. A to the power 1 is a. So since we have a raised to the power 1 by 2 square, why square? Because it is repeating itself. A to the power 1 by 2 into a to the power 1 by 2. If we have a to the power 2 into a to the power 2, what it becomes? A to the power 2 square. Or if we have a into a, what it becomes? Simply a square. So here also a raised to the power 1 by 2 into a raised to the power 1 by 2, it will become a raised to the power 1 by 2 square, and this has a value of what we have obtained, a. By transposing this square to the opposite side, it becomes a 1 by 2 equals to root of a. Similarly, if it is a 1 by 3 cube or a 1 by 2, okay, let's take another example. We have first let us erase this. So if we have a raised to the power 1 by 3, this should be cube root of a, is it? So just like in the previous case, a raised to the power 1 by 3 into a raised to the power 1 by 3 into a raised to the power 1 by 3. What do we get? A raised to the power 1 by 3 plus 1 by 3 plus 1 by 3 from the laws of exponents, because you have already stated that if it is a to the power m into a to the power n, it becomes a to the power m plus n. The powers get multiplied. If it is a to the power m into a to the power n into a to the power k, it will become a to the power m plus n plus k. So here we have a raised to the power 1 by 3 plus 1 by 3 plus 1 by 3, it is a. So this is what? This is a raised to the power 1 by 3 cube equals to a. By transposing this to this side, you get a raised to the power 1 by 3 equals to cube root of a. So in these two examples, we find if there is a raised to the power 1 by n, it will become the nth root of a. Clear? We have covered this as well. Now the last one, the last law of exponent, that is remaining, a raised to the power minus 1 by n equals to 1 by nth root of a, or you can say 1 by a to the power 1 by n. See, this a raised to the power minus 1 by n, this previous law of exponent will help you get to know about this. You can write this as minus 1 by m or minus 1 into 1 by n, or even before that you already know that minus sign is for making the number reciprocal. Whatever it is, it will come into reciprocal. So this will become, if we have a raised to the power minus 1, it becomes 1 by a. If we have a raised to the power minus 2, it becomes 1 by a2. If it is a raised to the power minus n, it becomes a raised to the power n, reciprocal of this. So if we have a raised to the power minus 1 by n, it will become 1 by a raised to the power 1 by n. Only the minus sign will get lost from here and it will be treated as a to the power 1 by n. Forget this minus sign after you have already made this as a reciprocal of the number given. So here, if you forget the minus sign, if you forget this minus sign, what you will be left with? A to the power 1 by n. So this minus sign will only help you to get this. So we have a to the power minus 1 by n as 1 by a to the power 1 by n. Now you have already come across this, that this thing is nothing but nth root of a. From this property, a raised to the power 1 by n is nth root of a. So a raised to the power 1 by n is nth root of a. Students, this is all about the laws of exponents. Hope you are able to understand the basics of how these exponents and their laws were concluded and written in these forms. So this is all for today's class. In the next class, we will be solving the questions of laws of exponents. It is important to learn all these so that you can easily solve or crack down the questions from this laws of exponents. So this is all for today. Hope to see you soon. Take care.